Hi folks, my name is Steve and I'm a Field Applications Engineer with MultiConnect Systems. Today's video will focus on the new features added with AEP Firmware Release 1.4.16. Let's start with a brief LoRa overview. LoRa is an acronym for long range and is a proprietary sped spectrum modulation developed by Simtex for low data rate, low power, and long range wireless communication. LoRaWAN, on the other hand, is a wide area network protocol specification for use with the LoRa modulation. The LoRaWAN protocol specification is published by the LoRa Alliance. Public LoRaWAN networks are typically a star topology where gateways relay messages between end devices and a central network server. In this configuration, end devices communicate via a single hop wireless communication to one or more gateways, which in turn are connected to the central LoRa network server using standard IP connections. All variations of multi-text conduit gateways can be configured as a gateway that will forward packets to a public LoRa network server. Examples of typical public LoRa network servers today are Actility, Laureate, the Things Network, Senet, OrbiWise, and Stream Technologies. In MultiTech's private LoRaWAN network configuration, the MultiConnect Conduit with a LoRa M card installed functions as both the gateway and the central network server. The conduit is highly configurable and can publish data to the cloud via the onboard Ethernet connection or an optional cellular radio. By default, the device is configured in public LoRaWAN mode where the radio is able to receive packets intended for a large wide area network with a central LoRa network server. But it can also be configured to operate in private LoRaWAN mode with the benefit to filter out public network packets at the radio. Private MTS mode is the legacy default mode for multi-tech LoRa end devices before firmware version 3.1. The join delay was shortened to 1 second to be used with a local join server on the conduit, and the United States and Australian downlink frequencies are set according to the frequency subband setting rather than according to LoRaWAN protocol. This mode is provided for backwards compatibility with existing LoRa end device firmware. It is designed for an 8-channel LoRaWAN network. If support for more than 8 channels or a cloud join server is required, or maybe in the future, public or private LoRaWAN modes should be used. Communication between LoRa end devices and a gateway is spread over numerous frequency channels and data rates, so a single gateway can accommodate a large number of end devices in challenging wireless environments. Data rate is directly related to spreading factor. Spreading factor determines the amount of redundant data spread across the transmission. A high spreading factor means a large amount of redundant data is transmitted and results in longer range, but a lower data rate and smaller packet payload size. To confirm packet reception, acknowledgments can be requested from the receiving device, but at the cost of reducing effective throughput. For an end device to participate in a LoRaWAN network, it must be authenticated via an over-the-air join or via an offline configuration called Activation by Personalization, or ABP for short. MultiTech's M.dot and X.dots are assigned a globally unique 8-byte dev EUI in the factory. This can be seen by looking at the sticker on the dot or queried through its firmware. In addition to the device EUI, a network-specific 8-byte app EUI and 16-byte app key are required for authentication. The app EUI and app key are both user-defined and must be set in the network server and in each end device. The app EUI is transmitted over the air and is used to distinguish between networks. It is comparable to a Wi-Fi SSID. However, the app key is never transmitted over the air and is used to independently generate AES 128-bit encryption keys on the network server and on the end device. These encryption keys are also never transmitted over the air. Each end device has a different set of encryption keys. This ensures the rest of the network remains secure if one of the keys were compromised. After joined, all packets transmitted between the end device and the server are encrypted with these keys. The latest firmware update to the AEP and MLinux conduits provides a major upgrade for the LoRa network server in the system as well as the user interface. One of those features is support for multiple gateways configured as packet forwarders reporting to a single LoRa network server. This has been added to increase network area or supported frequencies. In this configuration, the conduit supports a maximum of 2,000 LoRa end devices and up to 10 additional gateways connected at one time. An end device is considered connected when the LoRaWAN keys or session information is configured on the conduit. The conduit graphical user interface will now show queries to the network server for packets, gateways, and downlink queue. So next we'll take just a brief look at the AEP version 1.4.16 features. The first feature is the master-slave configuration, where we can configure one of the conduit gateways as a master or as the LoRa network server, and then up to 10 additional gateways as packet forwarders or slaves to that server. And this will increase the overall coverage of the network and expand the network. It does not increase capacity. Capacity is still capped at up to 2,000 devices maximum, but it does extend the range of the network. In the most basic network topology or configuration, the LoRa endpoints will register to the MultiConnect Conduit gateway configured as a LoRa network server. And this in turn allows our customers to create their own private LoRa network. Typically these endpoints are connected to sensors, and so the endpoints are relaying sensor data to the gateway at an interval. And then the gateway will relay that up to the cloud. It could be the customer's own server or it could be a cloud-based system. With the new firmware, we can support multiple gateways configured as packet forwarders reporting to a single gateway that is configured as the LoRa network server. In this case, we can have endpoints joining the network server through these conduit slave gateways configured as packet forwarders, and can greatly increase the network range. And then third configuration is where the MultiConnect gateways are configured as packet forwarders, where endpoints will join and register with a public LoRa network server like one mentioned earlier. So those are the three primary network topologies and configurations. Regarding using the conduit as the LoRa network server, it can store local keys of the endpoints. So it's a single place to manage these end device keys. And this feature will also expand the network by being able to configure multiple gateways as packet forwarders reporting to one gateway configured as the LoRa network server. These gateways also support multiple channel plans. Europe 868 megahertz, US 915 megahertz, India, Australia, AS923, which is a channel plan for about a half a dozen countries, and then Korea at 920 megahertz. So investing in a single conduit platform for worldwide coverage. The conduit has also been enhanced when it's configured as the gateway and network server to provide end device statistics and logs. So this makes it easy to view and manage all gateways and end devices, and gives you a real-time view. The new firmware also provides some security enhancements that provides a higher level of security for the device. So next what we're going to do is we're going to demonstrate the conduit's new firmware by configuring one of the gateways as the LoRa network server, and then two of the other gateways as packet forwarders or slaves. So first I'm going to log into and go into the conduit we'll configure as the LoRa network server. Once logged in, the home page will be displayed. So I'm going to select the LoRaWAN tab and then network settings. I'm going to configure the LoRa mode for one of the three modes, as either a network server or a packet forwarder. So this one we will configure as the network server. We'll double check that we're using the channel plan we want, which is US 915. We'll also set a frequency subband to listen on. In this case, I'll configure this one for frequency subband 7. As far as the network mode, I'm going to configure it for private MTS. And I'll scroll to the bottom and submit those settings. Next, I'm going to go into the key management section, and we can actually configure the keys for one of the endpoint devices. So if I add new, I need to put in the device EUI, which in this case is 00800000040002 FA. Next, I need to put in an 8-byte app EUI. And after that, a 16-byte app key. And then I can set the class. The class will be either A, B, or C. Today we'll use class A, and if I select finish, it will add this endpoint to the conduit configured as a LoRa network server. The last thing I have to do is configure the firewall. I need to open the firewall to allow the ports of the other two gateways configured as packet servers or packet forwarders to register. So I'm going to add a filter rule, which I'll just say allow packets is the name. And the destination IP, destination mask, destination port. We're going to do a range of ports, 1780-1782. So from 1780 to 1782, and we're going to accept those packets. I'll select finish. And now we see that this firewall rule has been added to allow packets through ports 1780 and 1782. And so next I will do a save and restart to make these changes in effect. So while this device is rebooting, let's go and configure one of the other two gateways as a packet forwarder. So I'll go ahead and log in. And once the home screen comes up, I'm going to select the LoRaWAN tab and network settings. For this gateway, we want to configure it as a packet forwarder. And as a packet forwarder, I can have it listen on either the same frequency subband or a different frequency subband. So the last one was 7. We'll set this one to frequency subband 5. We'll make sure the channel plan is what we want. Since I am using private MTS mode, we'll make sure that public is unchecked. And then I have to scroll down. I also need to point it to the IP address of the LoRa network server, which is 192.168.2.232. I will submit that. And next, have to do a save and restart for those settings to take effect. While that's rebooting, we'll go ahead and configure our third gateway. And we'll configure this gateway also as a packet forwarder. Once the home screen comes up, we'll select the LoRaWAN and network settings. And the mode will be set to packet forwarder. So as a packet forwarder, I'll make sure the channel plan is correct. And on this one, we can set we can listen on a different frequency subband. We'll set it to 3. We're listening on 7, 5, and 3. I'm going to make sure that public is unchecked because we are using the private MTS mode. and then I do need to point it to the LoRa network server at 192.168.2.232. And I'll also submit that. And I'll do a save and restart. Okay, so let's configure the endpoint. AT amper F, we'll set it to factory default. AT amper W, we'll store that setting. And let's configure the device. So we're going to set the frequency subband AT plus FSB equal 3. Now let's set the keys. AT plus NI equals 0, comma, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Let's set another network key, AT plus NK equals 0, comma, 1, 2, 3, 4, 5, 6, 7, 8. This one was 16-bit. We'll check the transmit power, AT plus TXP question mark. Transmit power is 30. Let's back that down because I'm in close range. AT plus TXP equal 15. Let's set the data rate, which is the spreading factor, how much redundant data is being set. AT plus TXDR question mark. We're at data rate 0 with spreading factor 10. That gives us the longest range and uses a 125 kilohertz channel. So let's go AT plus TXDR equal 3. And AT plus TXDR question mark. Data rate 3 sets spreading factor 7. So that gives me more payload. AT ampersand W and ATZ to reset. With that, I'm going to attempt to join AT plus JOIN. And I successfully joined the network. So now that I have successfully joined, I'm going to send some data. And I'll even send at an interval here. So AT plus send at an interval equal 1,000 milliseconds. Hello, world. So once a second, I'm transmitting hello world. So with that, I'm going to go back into my gateway configured as the LoRa network server. Okay, I'm going to go into my LoRaWAN settings, and I'm going to click on the Gateways tab. And the Gateways tab will show that I do have one of my gateways has registered, .138, and we can see packets received. We see all the different channels here, and we see that I am periodically receiving packets, and the packets are incrementing. Down below here, we see some network statistics. Under device configuration, we do see the one endpoint that has successfully joined the server. And if I look under device sessions, we also see this endpoint that is successfully joined. We see this has an up frame count of 20. So, and it was last seen 1 minute ago. Down frame count is 0, which means it has not received any data. If I click on the packets tabs, we're able to see packets. Now I only have a single end device join sending data, but we're able to see those packets coming in. And the Dev UI, which should not change because it's a single device, the frequency we receive the packets on, the data rate and bandwidth, and then the signal to noise and RSSI. The size of the packet, the frame count, and then the type, whether it's an uplink packet or a downlink packet, and then kind of a time frame when it was received. Below that, we see the most recent join request, which was from the same device. And then below that, we see received packets. And there is a time, a frequency, a data rate, the CRC, which is a cyclic redundancy check, passed, which means it's a valid packet. We see the signal to noise ratio, RSSI, and the size of the packet. So from there, I'm going to click on Apps and launch Node-RED in a different tab. Node-RED is a graphical programming environment, and that's included. And when the Conduit Gateway is used as a LoRa network server, it's a method to offload packets to an MQTT server or HTTP server or TCP server or a UDP server. But to do this, I need to pull out a LoRa input node, and I will scroll down and pull out a debug node and connect the two together. And the LoRa input node means anything coming into the gateway, any LoRa packets coming into the gateway, I'm going to push to the debug mode. And once I deploy this flow, I'm going to select the debug tab, and I should see my hello world packets coming in about once every second, which I do. So we've had some good success. So that's a demonstration of using the master-slave configuration in the new firmware, where we configure one of the gateways as a LoRa network server and then multiple gateways as packet forwarders. Everything that I covered today you can find on multitech.net in even more detail than I had covered here. To find it, log into multitech.net and click on the MultiTech Conduit Gateway. From there, scroll down and select LoRa. From there, select AEP, Getting Started with LoRa. Scroll to the bottom and select AEP 1.4.16 Upgrade Guide. This guide will describe all the fields and configuration that we went through today, and then some. And then also notice we have a troubleshooting guide right next to that too, which is very useful for troubleshooting. So with that, thank you for watching, and watch for my next video. Thank you. Have a great day.